Quadratic expressions and equations. We've learned how to expand expressions of the form a into x plus y. Each item in the bracket is multiplied by the term outside. That is 3x into 4 plus 5 is equal to 12x plus 15x. Minus 3y into x plus 2y is the same as minus 3xy minus 6y squared. Binomial expansions. An algebraic expression consisting of two terms is called a binomial expression, that is bi for 2. For example, 3x plus 1, 2x minus y, and so forth. Since x into y plus z is equal to xy plus xz, then a plus b times x plus y is equal to a times x plus y plus b times x plus y, which gives us ax plus ay plus bx plus by. Equally, p minus q times r plus s is equal to pr plus ps minus qr minus qs. The terms a plus b, x plus y, p minus q, r plus s is taken as one entity. For example, x plus 4 times y minus 3 is equal to x into y minus 3, 4 into y minus 3, giving us xy minus 3x plus 4y plus 2. Similarly, x plus 2y times 2y minus 3x is equal to x into 2y minus 3x plus 2y into 2y minus 3x, giving us minus 4xy minus 3x squared plus 4y squared. Binomial squares. In arithmetics, 2 squared is equal to 2 times 2. The same applies in algebraic expressions. X plus y squared is equal to x plus y times x plus y. X plus y squared is not equal to x squared plus y squared. Never do this. Examples: a plus b squared is equal to a plus b times a plus b, which is equal to a into a plus b plus b into a plus b, which gives us a squared plus 2ab plus b squared. A minus b squared is equal to a minus b times a minus b, giving us a squared minus 2ab plus b squared. 2x minus 4 squared is equal to 2x minus 4 times 2x minus 4, giving us 4x squared minus 16x plus 16. Quadratic expressions. It's an expression of the form ax squared plus bx plus c, where a, b, and c are constant, a is not equal to 0, and x is a variable. For example, x squared plus 2x minus 6, 2x squared minus 3x plus 5. Factorization of quadratic expressions. In an expression such as 2x squared minus 4, the factors are 2 into x squared minus 2, hence 2 and x squared minus 2 are the factors. So how then do you find the factors of a quadratic expression? x plus 2 times x plus 3 is equal to x squared plus 5x plus 6. The factors of x squared plus 5x plus 6 are x plus 2 and x plus 3. Having the quadratic expressions, we can find its factors. For the expression x squared plus 5x plus 6 is equal to x plus 2 times x plus 3, note the following. 1. Coefficient of x squared is 1. 2. Coefficient of x is 5, that is 2 plus 3. The constant term is 6, that is 2 times 3. Taking another example, x squared plus 4x minus 5 is equal to x plus 5 times x minus 1. The coefficient of x squared is 1. The coefficient of x is 4, that is 5 plus minus 1. The constant is minus 5, that is 5 times minus 1. Generally, to find the factors of a quadratic expressions, ax squared plus bx plus c, follow the following steps. Step 1. Find two numbers a and b such that a times b is equal to a times c and a plus b is equals to b. A and b are the coefficients of x. For example, x squared plus 3x plus 2. Find a and b such that a times b is equal to 1 times 2, a plus b is equal to 3, and those numbers are 1 and 2. Replace 3x in the expression with the x and 2x, that is x squared plus x plus 2x plus 2. Then factorize. We get x into x plus 1 plus 2 into x plus 1. The terms in the brackets are the same and hence we take only one. Therefore we shall have x plus 2 times x plus 1. These are the factors of the expression x squared plus 3x plus 2. Another example, 2x squared plus 3x minus 2. A times b is equal to 2 times minus 2. A plus b is equal to 3. A and b are 4 and minus 1. We replace 3x with 4x and minus x. 2x squared plus 4x minus x minus 2. Then factorize. 2x into x plus 2 minus 1 into x plus 2. Take one of the terms in the bracket and we have 2x minus 1 times x plus 2. Perfect squares. 81 is equal to 9 squared. 9 is equal to 3 squared. 16 is equal to 4 squared. 81, 9 and 16 are perfect squares as opposed to numbers such as 10, 5, 7, etc. Equally, a plus b squared is equal to a plus b times a plus b, which is a squared plus 2ab plus b squared. A squared plus 2ab plus b squared is a perfect square. We know that an expression is a perfect square or not if we factorize. For example, show that the following are perfect squares. Number 1, 4x squared minus 12x plus 9. A times b is 36, a plus b should be 12, and our numbers are 6 and 6. We substitute 4x squared plus 6x plus 6x plus 9 factorize, we have 2x plus 3 times 2x plus 3, and this can be replaced by 2x plus 3 squared, and therefore the expression 4x squared plus 12x plus 9 is a perfect square. Number 2, y squared minus 6y plus 9. Our numbers are -3 and -3. Therefore, y squared minus 3y plus 9, we factorize and we end up with y minus 3 times y minus 3, which can be y minus 3 squared. Difference of two squares. We saw that a squared minus b squared is equal to a minus b times a plus b. Generally, the difference of two squares is the product of their sum and difference. For example, x squared minus 9 is the same as x squared minus 3 squared. This is written as x plus 3 times x minus 3. For x squared minus 16, we first factorize, we get 4 into x squared minus 4. The terms in the bracket is a difference of two squares, that is 4 into x squared minus 2 squared, which can be 4 into x minus 2 times x plus 2. An example, factorize the following: x squared minus 1, b x squared minus 16, and c 2x squared minus 8y squared. In our solution, x squared minus 1 is equal to x minus 1, x plus 1. b x squared minus 16 is equal to x squared minus 4 squared, which is x minus 4 times x plus 4. c 2x squared minus 8y squared is equal to 2 into x squared minus 4y squared, which is 2 into x squared minus 2 squared y squared, giving us 2 into x minus 2y times x plus 2y. Quadratic equations. These are equations that take the form ax squared plus bx plus c is equal to 0, where a, b, and c are constants and a is never 0. Such an equation where the right-hand side is 0 is called a standard quadratic equation. When solving quadratic equations, it is necessary to write it in the standard form. Quadratic equations always have two answers. Solving quadratic equations. Note that the difference between an expression and an equation is that the latter has equal signs. That is, x squared plus 5x plus 6 is equals to 0 is an equation. X squared plus 5x plus 6 is an expression. Let's solve the equation. We first factorize the equation. X squared plus 5x plus 6 is equal to x plus 2 times x plus 3. Therefore, x plus 2 times x plus 3 is equals to 0. Now, assuming a times b is 0, it means either a, b, or both is 0. Equally, for the above case, either x plus 2, x plus 3, or both is 0. If x plus 2 is 0, then x is minus 2. If x plus 3 is 0, then x is minus 3. Remember, we said quadratic equations have two answers. Therefore, minus 2 and minus 3 are the solutions for the equation. They are said to be the roots of the equation. For example, find the roots of the following. A. 2x squared minus 18 is equal to 0. In our solution, we factorize and have 2 into x minus 9, and this is a difference of 2 squares, so we shall have 2 into x squared minus 3 squared, giving us 2 into x minus 3, x plus 3. If x minus 3 is 0, x is 3. If x plus 3 is 0, x is minus 3. The roots are therefore minus 3 and 3. B. X squared minus 14x is equal to 15. Write in standard form. X squared minus 14x minus 15 is equal to 0. Factorizing, our numbers are minus 15 and 1. X squared minus 15x plus x minus 15 is 0. Factorize x into x minus 15. 1 into x minus 15. We have x plus 1, x minus 15. If x plus 1 is 0, x is minus 1. If x minus 15 is 0, then x is 15. The roots are 15 and minus 1. C. 3x squared minus 4x minus 28 is equal to x. Write in standard form. 3x squared minus 5x minus 28 is 0. 3x squared minus 12x plus 7x minus 28 is 0. Factorize 3x into x minus 4 plus 7 into x minus 4 is equal to 0. 3x plus 7 times x minus 4 is 0. If 3x plus 7 is 0, then x is minus 7 over 3. If x minus 4 is 0, x is 4. Therefore, minus 7 over 3 and 4 are the roots of equation C. Forming quadratic equations from given roots. Roots are values that satisfy an equation. Do not confuse them with roots in square roots and cube roots. Simply, if given roots as a and b, to form an equation we simply have x minus a times x minus b is equal to 0 and then expand. For example, find the equation whose roots are a, 2 and 1, b, 3 and minus 2, and c, minus 2 and minus 5. In our solutions, a, x minus 2 times x minus 1 is 0, and we expand, we get x squared minus 3x plus 3 is 0. b, x minus 3 times x minus minus 2 is 0, we expand and we shall get x squared minus x minus 6 is 0. C. X minus minus 2 times x minus minus 5 is 0. X plus 2 times x plus 5 is 0. X squared plus 7x plus 10 is 0. Let's take a real problem. The product of two consecutive odd numbers is 63. Find the numbers. In our solution, let the smaller number be x. The larger number will be x plus 2 since two consecutive odd numbers differ by 2. Multiplying x times x plus 2 is 63. Expanding, x squared plus 2x minus 63 is 0 when we write in standard form. If we solve that, we shall end up with x plus 9 times x minus 7 is equal to 0. The roots are x is minus 9 or x is 7. Let's see if it is true. If x is minus 9, The smaller number is minus 9 and the larger number is minus 9 plus 2, which is minus 7. Minus 7 times minus 9 is 63, which is correct. Again, if x is 7, the smaller number is 7 and the larger number is 7 plus 2, which is 9. 7 times 9 is 63. Again, it is true. The numbers are either 7 and 9 or minus 7 and minus 9.
I think one of the problems with math is if you aren't strong in it, you end up with weak spots in the foundation. And so if you want to build on that, if you want to go in and major in it or to do honors in it, you really do need a solid foundation. And so if you don't have it, if you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university.